Okay, so we are still with our celebration of Jaime Escalante having desire, and I'm wearing the hat in his honor. So as we go on to topic 10.4, we're now going to add or subtract rational or radical expressions. And this is all from additional exercises, section 10.4. And these booklets are available here in Math Zone. So as we look at example 1, these are perfect squares. So we're just going to say 5 plus 4 will equal 9. Now as we look at example 2, right away we don't see like terms. But if we take the square root of 32 and divide it by 2, it gives us the square root of 16 times the square root of 2. Now, the square root of 16 is a perfect square. So from what we had mentioned earlier, you try to divide the radicand into a factor that is a perfect square, and then whatever's left over. So this is going to become 4, the square root of 2. And then this one was 72. And if we divided that by 2, we get 36 times 2. And 36 happened to be a perfect square factor of 72. So this then becomes plus 6, the square root of 2. Now, when we are adding radical expressions, we treat this just like they were like terms. If the radical part is exactly the same, then we just add the numerical coefficient. So then this will become 10, the square root of 2. Remember, when we're adding, the radicands doesn't change. And then in example 3 here, we see the square root of 18. Is there a perfect square factor of 18? Yes, 9. 9 times 2. So under one radical sign, you put the 9. And then the square root of 9 is 3. 3 times 3 is 9, the square root of 2. That's what this column becomes. And then here we have 50. Well, is there a perfect square factor of 50? Yes, 25 times 2. The square root of 25 is 5. A negative 5 times 5 is a negative 25, the square root of 2. Now we have like terms. So a negative 25 and a positive 9 gives us a negative 16, the square root of 2. All right, in example 4, as we go through the numbers, they're going to get a little more difficult. Square root of 75 can be divided into the square root of 25 times the square root of 3. And 147, I divided it by 3, and I got 49. So now there's a perfect square, 5, the square root of 3. Now, square root of 49 is 7. 3 times 7 is 21, the square root of 3. And again, we have like terms. We just add our numerical coefficient, 26, the square root of 3. So far they weren't too bad. All right, moving on to number 5. As we look at our terms, we see a like term there and a like term there. So remember there's a 1 in front of this one. So there's 1 and 6. That would give me 7, the square root of 2. And then this is a like term, and this is a like term. And we have a negative 2 and a positive 4 gives me a positive 2, the square root of 11. Now as we get into 6, these don't look like terms at all. Well, let's see what we have. We could take the square root of 9, which is 3. So this makes this 3x, the square root of x. So taking out the square root of 9 gives me a 3. 3x, the square root of x. Plus, watch this now. This is going to become, let's do it this way here. The square root of 16 is actually 4. The square root of x squared with 1x left over is x, the square root of x. So this is a perfect square, like so. So the square root of 16 is 4, square root of x squared is x, and there's an x left under the radical sign. And now we have like terms. So we have 3x and 4x is 7x, the square root of x. Now up over here, I worked it out a little bit for you. But again, what you want to do is simplify these radicals. So this is, there's a 1 out in front. That's pretty straightforward. Now 16 is 8 times 4. We're looking for a perfect cube factor of 16, which is 8. So this now becomes 1, the cube root of 2 so far, plus I'm going to take this 8 out as a 2. 2 times 8 is 16, the cube root of 2, minus, and then 54, I could take a 2 out of there, and it became a perfect cube factor, 27. So cube root of 27 is 3. Negative 3 times 3 is negative 9, the cube root of 2. So here we have one of these. So this is 17 minus 9 is going to be an 8, the cube root of 2. So this would be 8 minus, okay, yeah, that looks good. Okay, they are going to get a little more tedious as we go on, but again, you want a pattern to get correct answers. Okay, let's give these two a shot. I've worked them a little bit here. So this is the original example. I see the square root of 25 is 5, and what I'm left under the radical sign is x. And then here, the square root of 16 is 4, and this can be divided into x to the 4th times x. So x to the 4th becomes x squared, with an x left under the radical sign. So now we have like terms. And by the way, these have to be the same or similar like terms as well in order to add them. So we have 5x squared and a 4x squared gives us a 9x squared, the square root of x. And this one, even though it's long, it's not too bad. This you just bring down. This you just bring down. But here, when we have the cube root of 54, you recall it was 27 times 2. So let's write this again. 3, the cube root of 2, plus 8, the square root of 5. Now this is going to become, the cube root of 27 is 3. So 3 times 2 is 6, the cube root of 2, that's what was left. And then 125 is 25 times 5, so this becomes 5, the square root of 5. And then now we have a couple of like terms, this one and this one. So 3 plus 6 is 9, the cube root of 2. And then this one and this one is 5 plus 8 is 13, the cube root of 5. And these aren't like terms, so you can't do any more. Okay, so as we move into the last part of the addition subtraction before we start multiplication, we have a situation where we want to add fractions. Well, the first thing we're going to do is get common denominators, which will be 6. So we have to multiply this one by 2, and this one by 2. This one by 3, and this one by 3. So what we now have is this is going to be all over 6. And notice here we have x to the 5th. So this can be divided into x to the 3rd, x to the 2nd. So this becomes then 2x, the 3rd root of x squared, plus 3 times 3 is 9x, the 3rd root of x squared, and all of that is over 6. We now have like terms, so this will give us 11x, the cube root of x squared, all over 6. Every once in a while, you're going to find that if this were a 12 here, the 6 and the 12 would cancel out. They would want you to simplify that. All right, now in this next one, we're going to multiply as if we were distributing, and we multiply what's under our radical sign. So this then becomes the square root of 12x squared minus 3, the square root of 2x squared. And you might say, well, you've multiplied, but you haven't simplified. Now remember, you're looking for perfect squares under the radical. And that would be 4 times 3. Let me write it out here. 4 times 3. And then this is an x squared already. And this one is just the x squared is the perfect square. So the square root of 4 becomes a 2. The square root of x squared becomes an x, and you're just left with the square root of 3. So the product of these two are this, that simplifies to this. Minus, now this comes out as 3x, the square root of 2. And notice these are not like terms, even though they have the same coefficient outside of the radical sign. Now I'm putting up some of the work so that we can speed things up a little bit, but again, you have to be careful you copy them down correctly. And now you're multiplying 4 times 9 is 36. Cube root of 3 times the cube root of 9 is the cube root of 27. And then we go 4 times 7 is 28. The cube root of 3 times the cube root of 7 is the cube root of 21. Now you might think you're finished, but remember the cube root of 27 is 3. So this becomes 36 times 3 plus 2, 28, the cube root of 21. And 3 times 6 is 8. This is probably 108. Okay. And we can always check this too. Number 4. Yep, that looks good. Okay, number 13. Again, we're foiling. So we're going to multiply this by this. So 3 times 2 is 6. The square root of 2 times the square root of 3 is the square root of 6. Now when we do our outers, we go 3 times a negative 4 is a negative 12. 2 times 5, square root of 10. Now my inners, negative 2 times 2 is negative 4. 8 times 3 is square root of 24. And then my last, negative 2 times negative 4 is a positive 8. 8 times 5 is 40. Again, while that is technically correct, that's not the final answer because you can simplify. Nothing here. 6, the square root of 6. Now, these are not like terms. But the square root of 24 is actually the 4 times 6, and the square root of 4 is 2. I'm sorry, yeah, 2. Square root of 4 is 2. So 2 times negative 4 is negative 8, the square root of 6. Ah, we're getting some like terms here. And then this last one will be plus 8, but this is going to be the square root of 4 times the square root of 10. Square root of 4 is 2. 2 times 8 is 16, the square root of 10. Now you see we do have like terms. These are like terms, and that ends up being a negative 2, the square root of 6. And these are like terms, and that ends up being plus 4, the square root of 10. And it never hurts to check your answer here. 13. Yes, and they have these switched around, but that's okay that way.